Today's question is find the sum of the infinite series sine inverse of 1 by root 2 plus sine inverse of root 2 minus 1 by root 6 plus sine inverse of root 3 minus root 2 divided by root 12 plus up to sine inverse of root n minus root of 1 n minus 1 by root of n into n plus 1 up to infinity. He has asked. The options are a pi by 8, b pi by 4, c pi by 2, d pi. Okay, I will, if in the form of sine inverse or cos inverse it will come, you try to convert into, first you try to convert in tan inverse form. It can be easily solvable. First general term I will write TR is equal to sine inverse of root n minus root n minus 1 by root n into n plus 1, or I will write TR is equal to, sorry, not n, here I will write R, sine inverse of root R minus root R minus 1 by root of R into R plus 1. It is a general term. First you try to convert, in tan inverse form. Okay, if I will draw the triangle OPM. It is sine theta is equal to opposite by hypotenuse. This is root R minus root of R minus 1. Opposite hypotenuse is root of R into R plus 1, or I can write root R square plus R also, you can write it. Either this or this, it doesn't matter. Okay, now OM we have to find by Pythagoras theorem. I will write this as theta. By Pythagoras theorem, OM square is equal to OP square minus PM square. OP square minus PM square here. OM square is equal to OP R square plus, I will write directly OP square. I will remove the square root minus PM square. Root R minus root of R minus 1 whole square. Now simplification is here important. R square plus R minus of R minus 1 plus R minus 1 plus 2 root of R into R minus 1. Okay, if you solve it, OM square is equal to this R and this R will get cancelled. We can get R square minus R, minus of minus it will plus 1. This is again minus into minus plus 2 R minus 1. Okay. Here I will take R common in this. If I take R common, this will be R minus 1 plus, I will write 2 R minus 1 plus 1 here. Here it is in the perfect square format. Slightly adjustment. I can write this term as, first term as R into R minus 1 root and whole square it, plus second term, the middle term, 2 into R minus 1 into 1 plus 1 square. A square plus 2AB plus B square. It is in the form of A square plus 2AB plus B square. I will continue on the next page. Okay, now, this is OM square. OM square is equal to root of R into R minus 1 plus 1 whole square. If I take then OM will be root of R into R minus 1 minus plus 1. No need of plus or minus, it is in distance, it is in negative, positive only. OM is equal to, now in general term, in terms of T, here we have written as sine. I will write in tan. TR is equal to, in this triangle, TR is equal to PM by OM. PM is equal to root R minus 1. OM, I will write this only, first I will write 1 plus root r minus 1 into root r into root r minus 1. I will separate and write. See here, tr is equal to, Pm by Mp. Now tr is equal to tan inverse of it. Here it is sine inverse of, I will convert into tan inverse of Pm by Om. I should write here only tr is equal to tan inverse of Pm is root r minus root of r minus 1 divided by 1 plus root r into root of r minus 1. Now general term will become tr is equal to tan inverse x minus y by 1 plus xy. This will be tan inverse of root r minus tan inverse of root r minus 1. Now Sn is equal to sum up to nth term. N is equal to 1 is to r. Tr is equal to n is equal to 1 is to r tan inverse of root r minus tan inverse of r minus 1. Okay, see here, for n is equal to 1, n is equal to 2, n is equal to 3, up to infinity we have to solve. This is the general for Sn. Sn for n is equal to 1. First I will substitute n is equal to 1. This will be tan inverse of 1 minus tan inverse of 1 minus 1 is 0. This is for n is equal to 1. For n is equal to 2 plus, I will write vertically, tan inverse of 2 root 2 minus tan inverse of 2 minus 1 is 1 plus tan inverse of root 3 minus tan inverse of, it will form a telescopic form, tan inverse root 2 up to n I will take tan inverse n root n minus tan inverse of root of n minus 1. See students, this will get cancelled, this will get cancelled. Likewise up to, in the first term, in the first equation, the dotted line will remain. Here in the last second term will remain. If the second term will remain, then the last term will also remain. Other will cancel. If the first term will cancel, then the last term will also cancel. Okay. Now, likewise it cancellation gets. Sn is equal to tan inverse of root n minus tan inverse of 0 is 0. Tan inverse of 0 is 0. Okay. Sn is equal to now up to s infinity. This is n. Sn is equal to, I will write again, tan inverse of root n minus 0 or only tan inverse n. S infinity is equal to tan inverse of infinity. Okay, tan inverse of infinity is pi by 2. The answer is pi by 2. So here in this question, first you convert in tan inverse form. If you convert in the tan inverse form, then tan inverse x minus y it will come. Then if you simplify it, substitute the values, two terms will remain. It will find, we can find Sn, and substitute for n is equal, if Sn is asked, then tan inverse of root n. If up to infinity means it will become pi by 2. Okay, now I will stop.